Welcome, guys. Today's lesson is going to be on methods of integration. Just before we start, though, there are a few things here that I'm going to assume that you already know if you're coming in to work on methods of integration. I'm already assuming that you know your product rule, you know your chain rule, you know how to find your derivatives. And so to make this video run smoothly, these assumptions will just have to be made, and I'll go ahead and simplify some of them here to make sure we've got them down. Before we can go ahead and start it, here are a few simple rules here that we have to make sure we've got down, and this will be really important as we move on to the next stage. Rule number one, your sums and difference rule. Okay, you got to know this one. Sums and difference. What do I mean by sums and differences? Remember this, that the integral of f of x plus or minus g of x is going to be equal to the integral of f of x dx plus or minus the integral of g of x dx. What I mean by this is if we're taking two functions and we're trying to find the integral between the two of them here, we can just go ahead and take them one integral at a time. The next one here is going to be our multiplication. And this is more dealing with constants here. This is a very, very important rule. When we have the integral of a function with a constant value, one of the things that we can do is put that constant to the outside and find the integral of our function. So constant to the outside, just like what we did there, and then find your integral. The next part here is going to be the product rule. Okay? You got to know your product rule. The integral of x to the power of n dx here, let me know what you guys think here. It's going to end up being x to the power of n plus 1 divided by n plus 1 plus a by c. And note, just for completion's sake, we usually say that n cannot equal 1, and that's because if n equals 1, then this n cannot equal, negative 1, because if n equals negative 1, then the denominator is going to end up being 0, and we can't have that. Right? There are a few other ones here that we also have to make sure we've got down. Your trig functions. You got to know your integrals. Let's start with the integral of sine of x dx. This is going to end up being the negative cosine of x dx. This is very, very important. The next one here, the cosine of x dx is equal to the sine of x plus c dx. Okay. Oh, I forgot the plus c on the first one here. That plus c is going to be important. If you forget it, you might end up losing some points. The integral of secant squared of x dx. I want you guys go ahead and leave a comment at the bottom here to let me know if you're able to get some of these. Tan of x plus c. All right, don't forget your values. And then finally, we have the secant of x, tan of x dx ends up being secant of x plus a by c. And that's going to be important for what we work on today. As always, guys, please leave a comment with any questions or feedbacks you may have. It just helps me make better videos. So our two rules here that we have to remember when it comes to methods of integration are use substitution, and integration by parts. Integration by parts. And I'll explain both of them here. Let's start off with use substitution. Use substitution is actually going to be coming from our chain rule. Right? Remember here that we said the derivative of f g of x, right? We have the function g of x that's inside of f of x, will end up being f prime g of x, right? The derivative of the outside times it by g prime of x. Now, here's where it gets interesting here. If I go ahead and move this to the outside, right, f prime of x, g of x times it by g prime of x here. If I take the integral of this, If I take the integral on the left-hand side here, remember if I take the integral of a derivative here, that's going to cancel each other out, and I'm just left with my original function here. All right, so this is a really, really important rule here to remember. By doing this here, we can use this rule to help us simplify some of our basic integrals really, really quickly. Let's take a look at this first example here. Let's see if we can find the integral of sine of 2 of x dx. To do this here, to use u substitution to solve this question, we must first figure out what we want u to be equal to. You always want to pick a u that's easy to find the derivative of. Okay? Unfortunately, this is a skill that comes with practice. The more you work through these questions, the more you get a feel as to what function you should set up as your u. Typically, it's going to be the inside function here. And so in this case, u is going to be 2x. And now find the derivative, du equals 2 dx. Now here's where it gets interesting. Notice here that we have a dx on this side. Now here's what we can do. I can solve for dx from this equation here. So that gives me dx is equal to 1/2 du. And then go ahead and plug it back into our original function. And so what I end up with here is the integral of sine of u dx here we said was going to be equal to 1/2 du. Why did I do it this way? Remember that we said here it's very easy to find our integral of our trig function if we don't have it nested in each other. And so using u substitution eliminates some of the complicated parts of having to solve for the integral of an inside term as well. To solve this down here, we now have a constant. That 1/2 is a constant. I can move that to the outside. And I'm left with this. Now before I go back to the screen here, see if you can find the integral of sine of u du. All right, we mentioned here that the sine of x dx is going to be equal to the negative cosine of x plus c here. And so in this case here, this becomes 1/2. Find your integral of this, which is just going to be negative cosine of u plus it by c. And now we just simplify it down. Now I go back and substitute things back in there. Remember this 1/2 here is being multiplied by this negative here. I can therefore put that negative on the outside. Cosine stays. What do I have for u? I said u here was going to be 2x. Don't forget your plus c. Right? To clean this up a little bit though, usually what you'll see in your textbook here is they will clean this up by having the top term here and then just dividing it by that 2, right? Dividing by 2 here is the same thing as multiplying by 1/2. And don't forget your plus c at the end there. And that's your answer here. Okay, let's go ahead and take a look at the second part here, which is going to be integration by parts. I'll put it down at the bottom here so it's a little bit easier to see. All right, integration by parts. Let's take a look and see how to solve using this rule here. Integration by parts is also another really interesting rule here that requires you to remember your product rule. Right, our product rule here says that dx of f of x times it by g of x is the same thing as f prime of x g of x plus it by f of x g prime of x. This is a basic rule that you have to make sure you've got down. Okay. Shuffling things around here, we can see just like what we did in the beginning there. I'm going to go ahead and move this here. If I just bring this back down here, I can see that this now becomes f prime of x, g of x, is equal to d dx of f of x, g of x, minus, right, I'm going to move this over to the outside, minus it by f of x, g prime of x. Now, let's take the integral on both sides and see what happens. Now, if I take the integral of the left-hand side, I get f prime of x, g of x, dx, is going to be equal to f of x, g of x. Remember that integral is going to cancel out this d dx here. And we're ending up with minus the integral of f of x, g prime of x dx. Right? And so to simplify it down here, most of the time we just use some substitution here. We usually call v f of x, and I'm going to call u here g of x. If I do that, this rule gets simplified really quickly to become the integral of u dv is going to be equal to uv minus it by the integral of v du. Okay? So now let's see how we can use this rule here to help us solve this next example. We have here the integral of x times it by e to the x dx. How do we know to use this rule? Well, look at it here. We have two functions, right? We have the x and then we have e of x. And so to simplify this down here, I'm going to call u my x. I'm going to, therefore, du is just going to be equal to 1 dx, or just dx here. dv is going to be equal to e to the x dx. Therefore, v had to have been e to the x. Okay? And so now let's see how we can simplify things down here. Using the rule, the top rule here. Watch what I'm going to do to simplify this down. This integral of x e to the x dx becomes u. What did we say u was? U is just going to be x times it by v. V here we said was e to the x minus it by the integral of v du here. V here was e to the x, and du here we said was equal to dx, so therefore we end up with just that. To simplify this down, the integral of e to the x is just e to the x. And so this now becomes x times it by e to the x minus it by e to the x plus it by c. So we just use u substitution and integration by parts to solve some basic problems here. Please continue to practice this to make sure you gain a better understanding as to what's going on here. As always, please like and subscribe to our channel here to support our channel. All right, take care, guys. Bye-bye.